In this episode, I want to show you why you should be using this setting in Cura and what it actually does. Let's go. Slicing tolerance in Cura is tucked away in the experimental settings section, where it has been for quite a while now, at least since 2017, where it was changed from being called slicing mode to being called slicing tolerance. Neither of these particularly explain what it actually does, so I will attempt, from a combination of poking around in the code to reading the documentation, to explain how Cura actually slices things and how this setting affects how things fit together. Because fundamentally that's what this setting does in practice. I have here 3 trays which correspond to the 3 settings available for slicing tolerance. The default is middle, with inclusive and exclusive being the settings on either side. I printed out a machine screw and a nut using all 3 settings, and on the middle setting it is quite tight and I would say largely unusable. On inclusive it's worse. Doesn't work at all, but on exclusive setting it works absolutely fine. Similarly with this print in place bearing, on inclusive setting it's pretty thoroughly welded together, you can't use this, but on exclusive setting it actually works fine. But on the flip side, this puzzle with a ring on it actually works better with inclusive mode than exclusive mode, so it's clearly not as simple as just a simple fix everything setting, nor is it simply a setting that just increases the spacing between elements. It doesn't work like that. That's actually a side effect of what it's really doing. So what is it really doing? I will attempt to explain this through the medium of awful drawings and Play-Doh. Cura is a slicer. Slicers slice models into slicers. Cura is no different. If you take any model and slice it into slicers, you get, unsurprisingly, slices of the model. Following so far? Good. Now in the real world, Cura needs to work out how to translate each slice into effectively a 2D shape. A cross-section is notably not the same thing as a 2D shape when 3D printing, because a 2D shape has no third dimension. But a 3D printed slice does, because each slice has its own layer height. So each slice occupies its own portion of the height of the model. It is not just a flat cross-section of the model. This is actually quite important. A spanner in the works of 3D printing these slices is of course that extrusion isn't the process of laying down cubic lines as much as Cura's maths might wish it does. If you look at extruded lines close up, they are very much not straight-sided rectangles. They probably are inside of a model, near enough, but at the edges where the outer walls meet the world outside, there's no constraints, so they are very much curved outwards. This already means that your cross-section, aka slice, is not what you think it is. It's less this kind of shape and more this kind of shape. Now for a cylinder, this is all very straightforward. Slices of a cylinder are just tiny cylinders. Stack a bunch of these tiny cylinders, this shape, on top of each other, and you will get a cylinder, broadly speaking. Sure, if you attack it with calipers, and if the resolution is low enough, that meaning the line height, you will be able to pick out wider and shallower parts of the physical part. But this is fine. You just have to set the resolution small enough. But what about literally anything else that isn't straight-sided? Most of the things we 3D print have what could be referred to as complicated geometry, meaning your slice might not look like something straight from a can of ham, but it might look more like this. How indeed do you turn this into one of these donut things? The first problem is that even the most basic slice from a sloping-sided cylindrical object has 2 distinct radii. You have a wider end and a narrower end. This is not the same as this. And this is where the slicing tolerance comes in. Cura has decided to tackle this problem by giving you 3 distinct choices. The first choice, the default, if you change nothing in Cura, it will use middle. When you choose middle, you're just slicing based on the radius straight down the middle of the slice, vertically speaking, and you're taking that to be the edge of the slice. Choosing inclusive, though, uses the widest point of the 3D model slice as the edge of the printed slice, and as you can probably guess, exclusive uses the narrowest point. Me from the future here, I've realised during editing that if I don't add a caveat here, I will get corrected in the comments. What I just said is broadly correct, except what actually happens is slightly more complicated. If you see the diagram here, you'll see that inclusive and exclusive modes use Boolean intersections between top and bottom of the slice. So the size of a slice is kind of the smaller or larger of all dimensions, which is quite complicated, but a distinction worth stressing. So what does this mean in reality? Well, only one of the 3 settings will actually end up with a physical printed model that fits in less space than the CAD design that you got the STL from, and that is the exclusive setting. Middle will be on average the same size as your CAD designed model, and inclusive will just be outright larger because every part of every slice where there's any kind of tapering is taking more width up than the model. You can see how this setting is useful then for a screw thread, for screw threads to clear each other. If your model has no tolerances built in, assuming your printer is spot on accurate, as I understand it, you can only make threads work if you choose exclusive mode. I've printed out a square-based pyramid and I've cut it exactly in half, and I've sliced and printed each half to demonstrate just exactly how stark the difference is between these slicing modes. One is inclusive, one is exclusive, and I've printed this in, I think, 3mm line width, on a 0.4mm nozzle. We've been over this. This is absolutely normal. You can do this. But anyway, this model shows the layer shapes really well, and you can see that one model is significantly larger than the other. So what's the takeaway here? Well, I've seen it said that you should slice with exclusive mode for parts that need to mesh together. You should slice with middle for parts that don't, and you should slice with inclusive for parts that you plan to sand down later. I think that's a good way to think about it, actually. Of course, that's not the whole story, because some people design in tolerances in their STLs to make settings like middle work, and then of course using exclusive would mean a part that's too loose. So you have to kind of deal with the setting on a piece-by-piece basis. Anyway, I hope that made sense. As always, please check the description for any corrections, additional info, links to designs used in the video. Also, if you feel like sponsoring the channel, then Patreon links below. Patreon sponsors have seen this video first, as I mentioned last time. This is something I'm trialing. Also, please consider joining our Discord. We're up to about 120 members now, which is way more than I ever expected. So come down and talk 3D printing with us. Otherwise, I'll see you next time. Thank you for watching.